Are we live? Hello, hello everyone. Are we live? We are just going to check once that are we live or not. Okay, we have to just okay, okay, we are live now. Yeah, I'm just going to check once. That's cool. That's cool. Okay, I was watching. Hmm. Let's start this multi-level classifications. So until now, each instance has been assigned to just have one class. Hmm. Okay, there is insect. Okay, okay, I am just going to explain in such a way so that you can understand it, and I'll be able to understand. Okay, so that is important. In some cases, you know what? Why I want to do or I am doing this stream. Two things are there. First is discipline, that I will be more disciplined to do this, and second thing is that I will be more modified when I will be reading in front of some audience or like no audience. I'm just recording myself and then again recording the same video that will be more concised, more better, and more better explained so that you can understand. Okay. So let's say one by one, we will be seeing line by line. But first, what is multi-level classification? Multi-level means there will be more levels. Simple. There will be labels. Which type of labels? Or what is the multi-label? So I am just going to open the good notes in which I am going to open this untitled book. Going to clear this page and let's start. So let's start with it. What is the multi-label? It's like we have a multiple labels. Like this is A, then this is B, then this is C. Okay, so there are different labels. Now anyone have to identify that. Okay, but let's say let's say you have a random sample. Now let's take a random sample. This is a random sample. Okay, so a random sample, you can call it D. Okay, so it's D, and so how it will be identified? Okay, how a neural network? Just let's make a neural network like this. This is neural network NN. How it is going to identify or give the output? So it will be identifying it first, and then it will be giving an output like this. Like it, if it is Bob, let's say it's Bob, then it will be giving the output like 0, 1, 0. Okay, 1 means true and 0 means false. I hope you got the point. Okay, so I am here, fountain moon is here. Okay, fine, that's fine. So this was the one thing that why it is called the multi-level classification. Now let's see its point of view. Okay, but in some cases you may okay each instance has assigned just one class. But in some cases, you want to classify to output the multiple classes of each instance. Okay. So consider the face recognition classifier. Okay. Then, okay. What should it do if it recognizes several people in the same picture? Okay, 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 okay. So this was the thing, guys. But now let's take a bigger picture. Let's take a bigger picture now. I hope you got the point. Now okay, there are three more people. We don't know any other people, but we know that this is A and this is B. Okay, and this is unknown. You lick the thing. Okay, so what will happen? That it will be identifying this is A and this is B. Okay, so how it will give the output? How it is going to give the output? It is going to give the output not zero. Okay, it's going to give one. There is a Bobby, then one. Alice is A is here, B is here. So it's like A, B, and C. So A is there, then there is one. B is there, then is one, and C is not there. That's why there is zero. So that's what you will get, you know. And from this, you'll be tend to know that there is a and there is a B in the picture. So that is the multi-level classification. Okay, I was actually before reading it, I was actually interpreting it wrong, but this is like a multi-level classification. Fine. So there will be multiple labels. Fine. What should it do if it recognizes several people in the same picture? So that's the point, guys. So it should tag each person it recognizes. So say the classifier has been trained to recognize three faces, Alice, Bob, and Charlie, means A, B, and C. Then when the classifier is known as the picture of Alice and Charlie, it should output true, false, true. Yeah. So if there will be picture of the Alice and Charlie, and it should output the true, false, and true. Yeah. So that's what I have told you, and that is called the multi-level classification system. So I hope you have got some understanding. And we will not go in the face recognition yet, but we'll be look at the simpler example just for the illustration purpose. Fine, we'll be seeing it. Okay, okay. There are a lot of things. So we have just reached on the coding part. So what I'm just going to do, I'm just going to open the code. Maybe this will be the code. Okay. This is not the actual code, I think. Um. Okay. Yeah. This is the error analysis. We have got the code for the error analysis, and we'll be in the previous videos we have seen the error analysis. So after that we'll be seeing. Okay. And what I'm going to do, I'm just going to write the multi-level classification. So this is going to be two multi-level classification. Okay. And this is the first. This is going to be error analysis. And what this is going to be? Modified classification code notebook. Error from Okay. I know this is the one of the longest name I have written ever, but yeah, okay, that's fine. So this is the error analysis. So you will have a one advantage. This is the error analysis. This is a multi-level classification. So that's what you will get. We are just going to add some in. Okay, fine. Then we are just going to copy this code here. Let's see it. Yeah, but it will be not working because we haven't run previous things. So we'll be run all. So it will be running one after another, and then it will be giving the output. So that is so simple thing. So what we are going to do now? So first we'll be seeing the theory that what's happening. Then we'll be seeing that what is the code. So this code creates a Y multi-label array containing two target labels of each digit image. Okay. So I really need a lot of water during the this is one of the big bottle I have. So so this is petrol for me. Like vehicles need. Let's see. Okay. The stream is not doing. Okay, stream is going well. And of course there are concurrent viewers zero. That's good. I'm enjoying my privacy. uh, um, the code creates y multi-level array containing two target labels of each digit image. So it what it is going to do, that it is going to take the image greater than 7, and it is also taking the train odd. So it is going to take the odd images. That's fine. So first, what it is doing? It is doing that it is making a Y multi-level array containing two target labels for each digit. So there are two target labels. Okay, two target labels. The first indicate whether it is large. If the digit is large, 7, 8, or 9. So it has defined that Y train large, that is greater than or equal to 7. So it will be 7, 8, or 9 because there is no tail. It is 0 from 9. MNIST data set. So I'm just going to show you MNIST data set. Yeah, this is the data. Okay, you can see a lot of digits. Okay, here lot of digits are there. So this is MNIST data set. This is one of the fundamental data sets. So this is first indicate this, and the second indicates the whether it is odd or even. That's fine. That's completely fine. Then the code creates the k neighbors classifier instance which supports the multi classification. Okay, so what it does, I'm going to explain that also so that you will have more clarity. That's what's going on. And the code creates the Y neighbor classifier. So it's like, sorry, K neighbors, like it is KNN. Okay. It supports the multi-level classification. Not all classifier do. And so you just have to, have in mind like KNN. Once I will be telling you, what is the KNN, then you will have a picture in your mind and you will be seeing that, okay, this is a multi-level classification. You can do anything from it. Now you can make a prediction and notice that output two levels. So it is going to predict the two levels. So let's start the game. But before that, I'm okay. Let's first start the game. Then I'll be telling you that what is the KNN. Okay. First, let's see the magic. Guys, code is literally the magic thing. Okay. Maybe we are getting some unwanted errors that we don't wanted. But okay, let's see. You container loop with signature matching type. Okay, I'm just not going to think much, but maybe we should also think. Like matching types are D types int 60 64. Okay, but okay, let's see here. What is the error? It appears that the error is caused by type mismatch. Okay, so okay, this is giving the string. Let's see, this is not a string. Then what will happen? Yeah, that's fine. Okay, so that is not taking as a string. There, that is number. Okay, I don't know why it is taking here as a string. We have modified the code, so maybe there will be you know, some error or something. Chains will be there. So this thing is showing that okay, there is something classifier has written. Okay, so we are going to get the sum digit. So how we are going to get the sum digit? We are going to see a random. Okay, not extreme. Np dot rand. Okay, np dot random. No, we are not taking any digit. We are going to take digit from x train. Okay, is it fine? Okay, x train is not defined. Maybe this will be defined. Why this error is there? Okay, okay, let's try this code. What it is doing actually, that it is indexing. So let's see. I hope this will work. And yeah, that works fine. And let's see. It is going to okay. So it is going to say it false. So I'm just going to do it again. It is false. Okay, so can it show the sum digit? Okay, I'm just going to write so the sum. Let's see. It will give true. This is one of the wonderful feature. So I don't know what is this. So this is zero. Okay. So what is this? Let's see. Yeah. Okay, this is the shape. Okay. So what it is actually doing? That it is going to take any number, I think. Hmm. And then it is passing through the extreme. So let's see. We are getting it or not. We are getting 4. Let's try it again. I don't know how many times we have to try it. Okay, we have got 9. Guys, 9 is greater than 7 and it is the odd number. That's why it is true and true. Okay. So I am just going to can we get this? Can I get this? That's fine. So I'm just going to print this. You know, we need to do something. F. I'm just going to use the F string, guys. Okay, this and this. That's fine. Mhm. And this digit is greater than and equal to 7. Okay. Okay. It's quite intelligent. So that's why it is giving. But what I'm going to do again, I'm just going to cut this and you know it's your creativity that how you are going to make the code beautiful. So that is important, guys. That is more important. And yeah, I hope you are enjoying this. I'm literally enjoying this thing because that's amazing. Fine. Now, okay, just refresh this. So what it will does this thing and this thing. So can we put a random seed? Yeah, we can do it. Yeah, so randomness will, it will be not random. Oh, it will be. Okay. Okay. So it have now, like it is now stuck, something like that. You can see, like, what I'm getting the value, it will get the value saved. But let's stick it not to the 0. I just want it to be more than 7 so that I can show you. Okay, it's 4, 0 again. Okay, it's 0 again. It's 1. Fine. So this is what I'm going to do. I hope. Oh, I don't know why it is taking only this, but yeah, that's fine. You can try it, okay, and you can play it at how many times you are going to get this. Okay, so I can just write it a digit greater than equal to 7. That's fine. That's fine, guys. Maybe I can do something like this. Yeah, you can just run it again and again, and you can also put the random seed np dot random seed. Oh, okay. Yeah. Then what we are going to get getting random index. Okay, then we are going to show print the output, the model. Okay, guys, I really don't know that why it is after making the random seed, why it is just getting the thick form. I don't know. Okay, one. Yeah, you can see here. The 7 is true and odd is true. So that's fine, guys. That was the thing we wanted to have. And okay. Yeah, that's fine. Next, we are just going to. So it's guess right. The 5 is indeed not large and not okay, fine. So there are many ways to evaluate the multi-level classifier. Okay. So what we are going to do now? We are just going to do the evaluation. There are many ways. So let's see how many ways. Selecting the right metric really depends on your project. So this is the important, guys. Yeah, it's confusing for many people. One approach to measure is the F1 score. Yeah, F1 scale is quite famous. We'll be seeing that. I also don't know about much um, about the F1 score, so I'll be also learning it. Yes. Okay. On each individual level, isn't there a pause button? Streaming. Okay, there is no any pause button, of course, but I can do like this. Fine. So one approach is the F1 score. So let's do the F1 score for each individual level or any binary classifier metric discussed later, then simply compute the average score. So okay, what we are going to do that we are now going to find the F1 score. Let's do that, guys. So I was not expecting this so much interesting, but it is now. And it is now going to predict, and you can see here this have also given this accuracy, but we are going to find the F1 score here. So it is actually predicting. Okay, F1 score is not defined. Okay, maybe it will be not defined, so not to worry. What we are going to do, we are going to take the F1 score, import F1 score. Let's see F1 score on the internet. You just need to search the F1 score always. So you can see here it is in the scikit-learn. So most probably from scikit-learn we will be importing it. Okay. So no need to worry. Okay, from sklearn, from matrix we can get the F1 score. So let's see. Let's have it, guys. Okay, no need to do all these things. That will be okay. Yeah. So you can see here. I'm just going to zoom it for you. 95%. Yeah. So it's 95% of the accuracy. I'm just going to multiply with 100. Is it fine? I hope. Okay, it's 95% of the accuracy. Okay, in it, it is 97%. That's fine. This approach assumes that all levels are equally important. Okay, so maybe there will be some, limitations. So, okay, I'm just going to remove this content. Yeah, convert to percentage. So I'm just going to get the F1 store. Okay, F1. Oh, okay. No need to do this all things. Just leave it. Okay. There is no need for this. Just keep it like that. So this approach assumes that the all levels are equally important. Okay, we find everyone equally important. We believe in the equality, but which may not be in this case in particular. If you have many more pictures of the Alice than the Bob or a Charlie, then you want to give more weightage to the classifier as put on the picture of Alice. So this is the thing, guys. You need to see this also. So that's what important. So that's why I'm going to make it pink. One simple option is to give each level a weight equal to its support, the number of the instances with the target label. Okay. So to do this, simply set average is weighted when calling the F1 SQL function. So average is not macro. It's not macro, it's weighted. So let's see and let's do it. What I'm going to do? Weighted. Wow. And let's see the okay. So there are little fluctuation, but that's fine. And why we are going to do this? That when there is imbalanced data set, so that we will give more weight to the more number of data points. Just more. Okay. So this is the thing we are going to do. Fine. So that is the beautiful thing about the F1 score. As if you wish to see a classifier does not natively support the multi-level classification as a SVC or a one possible strategy to train one model or label. However, this strategy may have a hard time catching the dependencies between the labels. For example, a large digit is twice more than likely than to be odd. So, but the classifier for the odd label doesn't know that the what the classifier for the last label predicted. To solve this issue, the model can be organized in a chain. When a model makes prediction, it uses the input features plus all the predictions of the model that come before the chain. So, guys, we are going to do maybe we are going to make a chain. So let's understand this problem. That what the problem is happening. But before that, we are going to see the KNN classifier. KNN classifier. Okay, let's see. First, what is the KNN? So it's like K nearest neighbors. Okay. So what is K nearest neighbor? I'm just going to tell you. Just have patience, be with me, and okay. So this explains well. I'm just going to paste it here. Let's see it will be work or not. Okay, it's beautiful, guys. It's really beautiful. Because it's transparent. there are, let's see that there are two categories or three categories. I am just making a more category like this. Okay. It's category C. Now there is a new data point, guys. Just see. Okay, okay. I am just going to use something else. Okay. What to use? Let's use the black. Yeah, we have a new data point. Yeah, as it have said. So you know what the KNN will do? So like if there is a new data point, then what it will do? It will actually find the distance between the neighbors like this, you know. And if it will be more closer to this data set, then it will say that okay, category B is the prediction. Or if it is category A, then it will be saying category A. So that is the K nearest neighbor. I hope you have a good bonding with your neighbors that most people usually don't have. So, so that's fine. And yeah, so that is about the KNN thing. Okay. So let's can we just okay. So if we can, we are just we are just making it like this. Let's see there is no data point. Okay. Because it is in between it. So I am going to give the new data point like this. Okay. And I'm just going to remove this. Now what will happen, guys? What is going to happen? This is going to calculate the distance from this. And what is the nearest point? You can see here. So this is more nearest to the category B. The category B will be the answer. So that's the KNN, guys. K nearest neighbors. So what is the meaning of K? You know what is the K? So in the this K, we have find the three. We have distance from the three neighbors. So this K will be three. I hope you got. And if you will be get it from the four, then what will be there? There will be four, guys. Simple. So that is KNN. Now let's move forward. Okay. So yeah, let's go from here. If we wish to use a classifier that doesn't natively support the multi. Okay, one possible is to train. However, this may be a hard time capturing the dependencies between the. Okay. So if you want, if you want to use a classifier that doesn't support the multi-level classification like SVC. Okay. So I just want you to show the SVC. I usually forget SVC, machine learning. So it's support vector machine. So what is it? So it is something like KNN, but it's different than that. Okay. So what we are going to do? Okay, I'm just going to explain, don't worry. That doesn't natively support the multi-level classification. Okay. Then such as SVC. So there will be one possible way to train a one model per label is that strategy may have a hard time catching the dependencies between the labels. So it will be a hard time, capturing the dependencies between the labels. Like, there will be, we have given the two conditions. Like there will be a digit that will be large and larger than 7, like 7, 8 or 9, or that will be maybe the odd. So it will be not interconnecting these two things at the same time. So let's read that. For example, a large digit 7, 8, 9 is twice more likely to be odd than even. But the classifier for the odd label doesn't know what the classifier for large label is predicted. To solve this issue, The model can be organized in a chain. When a model makes a prediction, it uses the features plus the output or the predictions of the model. Okay. So I'm just going to make it simplify for you. What is it? Let's see. There is a one model. So there will be different parts. So this will be what this will be predicting. This will be predicting that this is 7, 8, or 9. So this is then after that what will happen? Let's see there will be a 7. Then the classifier has second part, something like this. So this will go this, and that will be predicting that this is odd or not. Okay. So okay, I'm just using a different pen. This is odd or not. Got it? So, if it is odd or it is odd, so it will be predicting 7 and odd. Or you can say true, true and true that we have got. So this is the thing, guys. And the good news is the scikit-learn has called the chain classifier. So we have this thing, guys, that does that does just that. Okay. So it's like tongue twister. Dutch, Dutch, just that. By default, it will use the true labels for training, feeding each model, appropriate labels depending on your position in the chain. But if you set hyperparameter, it will use the cross validation to get clean predictions from each model for their instance to the training set, and these predictions will be then used to train all the models later in the chain. So what will happen? It will be using the cross validation. It will be getting the predictions like this. Okay. So first it will be getting the predictions like this. Then it is going to okay. I'm just going to use this pen. Okay. So it will be making prediction that it is 7 or not by the okay. And then this will be moving the chain. So like this is the chain and this is the chain, and we are getting the output here. Got it? I hope you got my point. So that is the point, guys. And here is an example showing how to create a chain classifier using the cross validation strategy. So we will just use the 2000 images for the training. Okay. So let's do that. Let's do it beautifully. It is going to, okay, it will take little time. And okay, SVC is not defined. That's fine. So SVC import. So we can import the SVC from scikit-learn, of course. So let's see. It will be used in the code to import the SVC. How we can import the SVC? Okay. From sklearn.svm, we can import the SVC. So actually you don't need to memorize all the things. You are someone who is a problem solver. You be seeing the things on the internet. Okay, you can see why it's beautiful. It's looking beautiful, and you can see the array is 1 comma 1. Okay, so it is actually doing the prediction on the sum digit. So you can see here it is true and true, means it's true and true. So that's fine, guys. We have got the same answer, and if you'll be changing it, if you'll be changing it, then it will be also changed. Okay.